right, from the beautiful studios of Way Happy, this is 7.4 partial fractions. And what are partial fractions? Partial fraction decomposition is when we take a fraction and we break it into two parts now or more, right? So this fraction right here is really cool. Well, in calculus, it might be hard to work with that fraction, and you wish you could break it into smaller fractions that still add up to it. And so that way you could work with them independently. And that's what we do here. We broke that fraction into these two. Now you're kind of used to going the other way. I give you two fractions and you get a common denominator and you put them together and you make one fraction, which looks prettier. But again, maybe that's so complicated that it would have been easier if it was two separate fractions. So that's all decomposition is. How can you break a fraction apart? All right, so here go the rules. Writing decomposition of fractions. First off, if the degree of the top is bigger than the bottom, then you know what? You need to divide it out. And so once you divide it out, you will get, a nice, pretty value. And you will also still get a fraction that then you can then decompose into little fractions. And so how will I do that? Well, I will factor the bottom completely first. And then once I factor the bottom, I will represent every bottom with a factor as kind of like one of the sums that will build up to the original. So the tricks to learn here are this. So somebody gives you something, you factor the bottom. And so you can see I have a factor of the bottom. And if it's a linear factor, meaning x to the first, I'm only going to put a variable on top. That means it's just going to have some number on top. If it's a quadratic factor, then, quadratic factor, underline the wrong one, then I am going to use a linear numerator. Okay, so you're going to have these different numerators depending on what your factors on the bottom are. Now, this is a big key right here, and you can probably see it next to it. If you have a multiplicity, then you have to represent every multiplicity in your decomposition. So since this was to the third power, I had to have a linear, to the first power. I had to have to the second power, multiplicity of 2, and I had to have a third. I have to represent every multiplicity as a separate fraction for me to decompose it down into. So that's a very key issue in remembering decomposition. So linear factors, if you just look at the factor, if it's a linear x to the first, just use a letter. If it's a quadratic factor, or irreducible quadratic, then use a linear numerator, and then make sure you represent everybody's multiplicity. All right, sounds a little crazier than it is, so let's start slowly. Let's just set up the decomposition here in this example. So as you can see, I'm going to set it up, all right? So I'm looking at it now. Believe it or not, that's a linear factor because it's really just x times x. It has a multiplicity of 2. So the first decomposition I'm going to have is I'm going to have x, so I need a variable for it. And then I need another one of those because it's x squared, it has a multiplicity of 2. So there's your second multiplicity, and I'll give that variable b. And then I see a factor of x plus 3, which has a multiplicity of 1. So I'm just going to have that. It's linear, so I'm going to give it a c. And then I see an x squared plus 1. That's another guy, and it has a multiplicity of 1, so it only needs one fraction. And I'm going to give that what? We got to go dx plus e, I guess. Ooh. And now you guys will have to solve for a, b, c, d, and e. That's going to be the hard part. But once we solve for all of those, we will have decomposed this fraction down to, in fact, 4 separate little fractions. That's all decomposition is. So again, let's set up this first one. So I will set, or the second one, I will set it up. It looks like I have a 2x minus 1. That's a linear factor. So I'm going to give it just a variable. And then I am going to set up this next one. Notice it has a multiplicity of 2, so I'm going to need 2 fractions. They're both going to be x squared plus 2, but one of them is going to have to the first power, and one's going to be to the second power. Now, these are quadratic, so this needs bx plus c, and this needs dx plus e, I guess would be good choices. And again, we will go through and we will solve for a, b, c, d, and e. Good? All right. Let me ask you a question, and I'll be right back. Excellent job. Now let's actually go through and decompose a fraction. So here you go. Now, the first thing is you want to make sure you factor. Notice the top is x to the first, linear. The bottom would FOIL out to be x squared, so that's quadratic. So since the top isn't bigger, we don't actually have to long divide, so that's good news. So now we're just going to break down. So I would factor down the bottom. I've saved some time by factoring it for us. And now I'm ready to decompose this. I have an x minus 4, and I have, and that's linear, so we'll just do variable a. And I have an x plus 3, and that is also linear, so variable b. And now we're all represented, so we're set up. So let's actually solve this. So what do you do? So now you have to set this up as you want to solve for a and b. So the first thing you would do actually in solving is put this back together. You would get this a common denominator, right? So the first thing you want to notice is you would give this guy an x plus 3 on top and bottom. That's legal. You would give this guy an x minus 4 on top and bottom. That is also legal. And all the denominators are the same. So cool thing is, now the denominators are all the same. Let's multiply everybody by that common denominator, and they are gone. So what do we have on the left side? We have 5x plus 1. But on the right side, I have ax plus 3a plus bx minus 4b. And you might say, well, that's kind of crazy. But here comes the magic. Notice what we have. We have a system of equations, believe it or not. We have an ax and a bx, two unknowns. I don't know what a and b are, but I know together they add up to 5, right? Because look at the x variables. It's a dead giveaway, right? I know that ax plus bx has to equal 5x, or most people would just say a plus b has to equal 5. And at the same time, I have this guy that has no x's. I have this guy has no x's. This guy has no x's. So a nice little hint there is that 3a minus 4b, that has to equal 1. So again, there's another equation. 3a minus 4b has to equal 1. And oh my goodness, look at the beauty, right? A system. You decide. Do you want to use substitution? Do you want to use linear combination? Do you want to use matrices? Do you want to graph it? I don't care, whatever you choose. So being that I am going to do this by hand here, I will say that a is equal to 5 minus b. So I will come to this equation and say 3, 5 minus b's minus a 4b is equal to 1. So notice I plugged it into the second equation. I got 15 minus 3b minus 4b is 1. So what's that? Negative 7b equals negative 14. So b must be 2. And if I know what b is, then a is 5 minus 2. A is 3. So a is 3. B is 2. And now I can jump up and down and say I found the partial fractions, right? Because I'm going to plug them back in. They would be, a was 2. I'm sorry, a was 3. 3 over x minus 4 plus b, which is 2 over x plus 3. And there is your partial fraction decomposition, or your decomposition of this fraction, right? So if you add those two fractions together, you will get what's on the left side. Again, why? Why? Because maybe it's simpler. Maybe we're doing something and we need all these little parts rather than that whole thing. So it makes our life a lot easier. And that's all we care about. All right, might as well try another one. Got one sitting here, so why not? Let's show you this bad boy. So he looks a little more confusing. He's got this one, which is an x minus 1, which is a linear. And he's got this other one, x squared, a quadratic, but at least it's only multiplicity of 1. But he's going to be bx plus c. But again, same kind of rules as you had before. Let's get everybody a common denominator. So this guy needs an x squared plus 1. This guy needs an x minus 1. Guess I should put it in parentheses so it's a little nicer. They will all have the same denominator now. So let's multiply everybody by that denominator, and whoa, it's gone. So we have x squared plus 4x plus 1 equals ax squared plus a plus, oh gosh, it looks like I got some foiling to do. What is that? Bx squared minus bx plus cx minus c. So you can see that beautiful work of art there. All right, what the heck does that mean? Well, again, let's look. We have an x squared term here, so let's look for x squareds on the right. I see an ax squared, I see a bx squared. That's it. So I can make you one very nice equation that says a plus b has to equal 1 because of the x squareds, right? Now let's look at the x's. This has an x in it. I see an x here, see an x here. That's it. So I can go ahead and say, what is that? B, negative b plus a c. So negative b plus a c, that has to equal 4. And then last but not least, all the stuff I haven't highlighted, right? This guy's a constant, that's a constant, that's a constant. Okay, sweet. So what do I got? I got a minus c has to equal 1. Well, I have this beautiful little system here that, again, I can now solve. I can use elimination. I can use matrices. I mean, whatever the heck you want, it doesn't really matter. Maybe even substitution might work in well here. Like I know that on this bottom one, I could rewrite this as a is 1 plus c. So why not take the 1 plus c, put it in here? So what would that give me? 1 plus c plus b equals 1. So c plus b equals 0. And I also have right below it, c minus b equals 4. So it looks like 2 c's equal a 4, or c is 2. Okay. Now I know that c is 2. I should be able to solve for everything. Go back. A plus, I don't know, b. A minus c is 1. So if a minus c is 1 and c is a 2, that means a is a 3. And if I know a is a 3, I should be able to go to the first one. 3 plus b is 4. Is 1. That means b is what? Negative 2? And so now I can tell you the answer, right? I can say it's 3 over x minus 1 plus, all right, b is a negative 2x plus a c all over x squared plus 1. And there is your partial fraction, or your decomposition of that original fraction. Feeling pretty good? It's not so bad, right? All right, let's take a break and answer another question. All right, beautiful work. And let's try a last one. So just to throw it all together for you again, here's another one. You can see that the numerator is definitely less, so I don't have to divide it. So that's good news. I can break it into partial fractions, but not yet. I need to factor this. So I think I got to factor it out in x. So I'm just looking at the denominator. X squared minus 4x plus 4. Ooh, and I think that factors down nicely. So to something like x times, what is that? X minus 2, x minus 2. So x minus 2 squared. All right, let's break that down now. So first one I have is x, and that's only a multiplicity of 1. So let's put an a on there. And then we have an x minus 2, but that has a multiplicity of 2. So we're going to have to do that for both of them. That's a really bad 2 there. But this is a b. They're both linear, so that's kind of nice. Well, good news. Now let's go ahead and get everybody the same so we can cancel out the denominators again. So I'll give this guy an x minus 2 times an x minus 2. So let's say x minus 2 squared. I will give this guy an x and an x minus 2. And I will give this guy, it looks like he just needs the x. So that looks a little more confusing than I thought. At least all the denominators will be the same. So that's good. Now, is that so bad? Let's see. I need to distribute the a through here. And so I need to FOIL this out. So this is x squared minus 4x plus 4, if you don't mind. This is what? X squared minus 2x. And I think I'm feeling good. So what on earth do I have? I have negative x squared plus 2x plus 4 equals, what do I got? Ax squareds minus 4ax's plus a 4a. And then I have plus a bx squared minus a 2bx. And then I have plus a cx. Now remember the rules. Plain and simple now, right? You see a negative 1x squared here. So who do we have? We have in front of the x squareds, we have an a and a b. So there's my first equation. My first equation will be a plus b equals negative 1. Then I will look at, in front of the x, I see a 2. And here I have a negative 4a. And then where's my other x? Another negative 2b. Ooh, and a c. Oh, that's a long equation. So it looks to me like, what did I say? Negative 4a. I'm looking at blue. Minus 2b plus a c. That has to equal 2. And then last but not least, the things that aren't highlighted looks to me like a 4a. 4, that's easy. So I have a 4a has to equal 4. Oh, that's beauty, right? Why is that so nice? Because we just figured out that a was 1. And if I know that a was 1, I can plug it in the first equation. I can get b is -2. And then if I know both of those, I should be able to plug them in here. So let's see, what is that? A was 1, so -4. B was -2, so +4 plus C equals 2. So C must be 2. And you have done your decomposition into fractions. Here it is. You have A, which is 1 over x, plus B, which is -2 over x minus 2. And last but not least, you have C, which is 2 over x minus 2 squared. And you have done it. Nice work. Stay happy. See you tomorrow.